Group 1I. This is our design prime synthesis of ethyl alcohol by direct hydrolysis of ethylene. In an ethanol production plant, ethylene and water are undergo reaction with direct hydrolysis to form ethanol product. A chemical plant does not only to run it smoothly and economically efficient, but first and foremost, safety. In order to protect people and the environment from any possible plant accident and loss, such as fire, explosion, reactivity, and toxicity. This project has three objectives. Firstly, identify the hazard of the separation unit involved in the process with distillation column. Secondly, perform a hazard study on the distillation column. Lastly, provide several recommendations to improve the safety aspect of the distillation column.
Hello, my name is Adila Alafi and I'll be explaining further on the hazards of distillation column. Hazards can be defined as anything that can cause possible damage, harm, or adverse health effects on something or someone. In this part, we have identified 5 different potential hazards, which are chemical, overheating, ingress of water, overpressure, and corrosion. One of the hazards involved is chemical present in the mixture, ethanol, which is highly flammable and reactive. According to the material safety data sheet, it has also been recognized that inhalation or of skin contact with ethanol vapors can be a source of localized irritation, where long-term or prolonged exposure may affect the upper respiratory system and the central nervous system. Next hazard is overheating, which can cause leakage that will result in flammability hazard. In the condenser, the substance is past the flash point temperature, and this could result in process upset and potential failure of programmable logic controller (PLC) or instrumentation in the enclosure. Another distinct hazard is the ingress of water in the distillation column. The rapid water expansion as it flashes to steam will cause very destructive overpressures. It may inflict significant harm as well as contribute to further and more expensive issues down the track. Ethanol production processes are moderately corrosive, with pH ranging from 5.8 to 2, which is light to moderate acidic in most parts of the production process. Many of these overhead corrosion consequences include leaking, maintenance and repair of facilities, processing costs, offset products, and downstream fouling of systems. The fifth hazard identification is overpressure in the distillation column. Unmitigated heat input can cause a state of overpressure and column rupture, and such implications include possible deaths and also accidents and property damages.
Hi, I'm Hida Sarina. I will be explaining about the Hazop study, which is used to identify potential hazards and operating problems for the distillation column to separate ethanol from water. Our study note is based on feed inlets to distillation column D101, and the parameters that we consider are the flow, pressure, and temperature. For the flow, the deviation that may be involved are no flow, more flow, and less flow. For no flow, the causes may be because of pump failure, shortage of feed, and pipe blockage, and the consequences from this failure may result in no separations of ethanol and water, since there are no flow of the feed into the distillation column. So, one of the actions to be taken is to install low-level alarm. Next parameter is pressure, where the deviation may be because of high pressure or low pressure in the distillation column. For high pressure in the distillation column, the causes that may be involved are pressure indicator controller fail to function, pipe blockage, or even cladding in the distillation column. Some of the consequences are low efficiency of separation, rupture of column and connecting pipe, product loss, or even explosion to the distillation column. Therefore, action to be taken are to install high pressure alarm or install pressure relief valve. Next parameter is temperature, where the deviation can be high temperature or low temperature in the distillation column. For high temperature in the distillation column, some of the possible causes are because of the failure in the instrumentation and more steam flows in the column. From there, the consequences can lead to changes in the product quality or even explosions to the distillation column. Therefore, some actions to be taken are to install temperature indicator controller, temperature alarm, and make sure to give attention to the heat input and output control.
There are a few recommendations that could be implemented to improve the safety of the ethanol processing plant. The first one is to install temperature indicator and temperature controller. Temperature indicator can be used to monitor deviation of temperature from the operating conditions, while the temperature controller is to regulate the temperature so it maintains an optimum condition. Besides that, safety relief valve can be integrated into the processing plant to prevent machinery loss through venting of excess ethanol streams directly into protected areas. Moreover, drains and overfill prevention system need to be constructed in the ethanol processing plant. This is to prevent spillage of and overflow of ethanol in the distillation column. Ethanol vapor detectors and automatic fire detection and suppression system need to be included in the ethanol processing plant to enable the plant operator to take prompt action in reducing the impact of the plant deviation. Inerting prevent risk of fire and explosion and exchange the air and fuel ratio out of the flammability region. Ethanol processing plant should use stainless steel as the material, as stainless steel has excellent track record in chemical industry and they offer excellent resistance to corrosion, good strength, high ductility and durability. Last but not least, hot work program should be implemented and source of ignition near the distillation column area like cigarette, fire and spark should be eliminated to prevent the risk of explosion.
To summarize, there are several approaches to hazard identification. Firstly, the potential chemical hazards for low material ethylene and ethanol product was identified through Material Safety Data Sheet (MSDS). The hazards include flammable, toxicity, and corrosive. The operating condition and the material construction also possess hazards such as overheating, corrosion, overpressure, and leakage of chemicals. Moreover, such a study was performed. The study known as Industry of Distillation Column D101. Parameters such as flow, temperature, and pressure are identified and guidelines are used to identify the process delay from steady state. Lastly, several recommendations are suggested to enhance the safety aspect of the process.